Okay, so we have C, which is very similar to B. Yes. So we want our delta x, x2, x1, I keep forgetting it's y. We want our slope formula equals the partial of f with respect to x over the partial of f with respect to y. And it is the negative of that. So that's our little slope formula. It's the slope of what? It's the slope of all contour lines at any given point, right? Okay, so what do we have right there? The partial of f with respect to x, this is going to be c. Partial of f with respect to x, remember y is held constant, equals 1/3. We're going to skip all the basic algebra. Who would write that? So x to the negative 2/3. I get 1/3 minus 3/3. Yes, y to the 2/3. Yeah, so that equals something like y to the 2/3 over 3 x to the 2/3 if we have our positive exponents. Yeah, so it's just algebra. It gets pretty messy. It is a homework problem. So the partial of that thing with respect to y is going to be 2/3 x to the 1/3. X to the 1/3 is held constant. Y to the negative 1/3, I have 2/3 minus 3/3, right? Which is something like 2x to the 1/3 over 3y to the 1/3. Yeah. So those are our two partials there. So what is it? If it's delta y over delta x, we need the partial of x negative the partial of x. Try not to make a mistake. Remember, how do you divide two fractions? Bottom one goes up top and flips. Just we're not thinking about the algebra. But we need negative x divided by y, so times the flip of y. What simplifies here? Okay, good. So that's 1 and that's 1. A 3 cancels. This is all good news here. Yes. This is kind of interesting here. What the heck? Yes, it is just 2. Y over 2x, that's fine. So get rid of all that. And the slope m, we don't want to write it that way, but the slope m, literally, if we understood all of that, just kind of rewind the video, 1/3 plus 2/3, the m is going to be that. So that's good. If we want it to be correct, we do a delta y over delta x, that is m. Yeah. And then this is our constraint. Yes. So we have that is our constraint. What do? We have the slope. Yes, so we do have the slope. And we do have, okay, that's right. I keep forgetting that part. It's easy to get stuck there. But we have our y. You can write less than or equal to, you don't have to, is negative x plus 2. This is our slope, and the slope has to equal the slope. Yeah. Slope of contour line is the slope of the contour line, and -1 is just the slope of our constraint line. So this has to equal -1. That's kind of the link. Yeah, so y equals -2x, y equals negative x plus 2. Then we literally just set them equal and solve for x there. I get -2 equals negative x plus 2x. I get -2 equals x. I get x equals -2. We plug it into our constraint. I'm just rewriting the constraint. It's literally just right everywhere. Our constraint is negative x plus 2. X is -2. So y equals -2 plus 2. Y equals 4. Okay, good. Yeah. So we have x equals that, y equals that. It's going to be maximized. We all have this down. So I just have to remember -2 and 4. yeah, y equals 4. Yeah, so f of negative 2 comma 4 equals negative 2 to the 1/3. Yes. And then 4 to the 2/3, which is fine. Those cube roots are cubes. You know, they are cubes, the cube roots, which means negatives are allowed inside of them. Yeah, it is negative 2. I get negative 2 times 4 squared. The entire thing to the 1/3. The cube root of that is what I get. Yeah, it's like, is this right? Anyways, negative 32. The cube root is what that is. That's 5 2s, 2, 4, 8, 16, 32. Yeah, that's looking to me like negative 2 radical 4. Okay, so I hate to think that we made a mistake. Anyways, we had kind of a pause there, but we just finished C, and we did get. It doesn't matter if it was f. What was x negative 2 and y was 4. It does come out to be negative 2 cube root of 4, which is a little odd. A max or a min. Um, It should be, maybe that's a min, but I don't understand exactly what the graph looks like. But anyways, it should be correct. So let's go on to D, I think, yeah. Okay, so this is the same, but it's the exact same process. This one, we just have other stuff that we have to deal with. So we're doing our little slope formula, yes. D, the partial of f with respect to x is what? Yeah, ax, a minus 1, y to the b. Yeah, the partial of f with respect to y is 8. X to the a is held constant, and it's b, y, b minus 1. Yes, those are those. So our slope, they don't call it m in the book. I'm just calling it 1 as negative. Yes, it is going to be negative what? If it's delta y over delta x, it's going to be negative partial of x over partial of y. So we have ax to the a, x to the negative 1, y to the b, divided by b, yeah, x to the a, y to the b, y to the negative 1. Hopefully we see what I did there, yeah. But good. So x to the a cancels, y to the b cancels. The x in the doesn't turn out too bad there. So m equals the negative a y over b x, yeah. M equals negative ay over bx. Yeah, and this crazy thing is a constraint, but it has x and y to the power of 1, so it is a linear equation right there. Yeah. Uh, okay, so this one's pretty gnarly. Maybe we'll make kind of a special video to this here. Hold on a second here. Okay, so we finish this one later, but we have our little equation here, our little slope, yeah. And if we do the constraint y equals mx plus b, we get that. So that's the slope. So you set it equal to the slope, and they just algebraically want us to derive things that are fairly gnarly here.